Good morning, students. Myself, G. Shankar from PC Department, Chevrolet Engineering College. Today, we are going to discuss about the examples of Z transformation. In the last class, we completed up to the a power n mu of n. That is nothing but in the previous class, the example is 0.5 whole power n mu of n. Coming to the next one is a power n mu of minus n minus 1. And next one, x of n, the 0.5 whole power n mu of minus n minus 1. Mu of minus 1 minus n minus 1 is a right-sided. It's a 0.5. A power n mu of n is a right-sided. I think but towards right-handed, right-sided. Okay. Now the mu of minus n minus 1. Actually, the mu of minus n is nothing but left-sided. Because it is a discrete, 0 to infinity is in the right-sided, means minus infinity to minus 1 is the left side. The range here, the 0 to infinity. 0 to infinity is a right-sided, and minus infinity to minus 1, because it's a discrete. Minus 1 value is a left-sided function. Okay. So mu of n is equal to 1 with n greater than or equal to 0, and 0 is less than 0. And mu of minus n minus 1 is 1 when n is here. Minus n minus 1 is greater than or equal to 0. Minus n minus 1 is greater than or equal to 0, and n is less than or equal to minus 1. Less than or equal to minus 1 means it is a range is from minus infinity to minus 1. Only the value is a 1. Got it, my students? The solution here, substitute in the x of z. Sum of n is equal to minus infinity x of z power minus 1. Z power minus 1. Now you can see it is a 0.5 only they given, but the derivative is a 0.8 here. Okay. Right, that is a 0.5, or otherwise you can keep that 0.58 on. Nothing is wrong there. It's a 0.5, and here also it is a 0.5, and this also is a 0.5, and this is a 0.5, and here is a 0.5. Got it, my students? Now I am substituting in this equation. So second term, whatever we have, that is a 0, because it is in the left-sided sequence. Minus infinity to minus 1 x of n z power minus n. Minus 1, infinity 1 minus 1, 0.5 whole power n z power minus n. Now, here one, you have to remember, I'm changing the limitations as negative to the positive. Changing the limitations of the n values, the negative values to the positive values, both values. Change the powers are positive to the negative, negative to the positive. So minus 1 is becomes a plus 1 here, minus infinity becomes a plus infinite, and 0.5 whole power plus n is minus n, and here the minus n, z power minus n is becomes a plus n. So limitations sign is changes, the power is also changes in that summation. So sum of n is equal to 1 to infinite, because it's a 0.5, derive this 0.5 whole power minus n, z power n. Okay. Now you can change this as a 0.5 whole power minus 1 whole power n, nothing but 1 by 0.5. Okay. I will show this in this term only. So 1 by 0.5 whole power n and z power n. I'm changing this negative by keeping the 0.5 in the denominator. So write this function totally, the 0.5 whole power n. Now it is in the form of a power n only. In the range of infinity to 1 or 1 to infinity. In the substituting the formula what we have, the a power n, sum of n is equal to n1 to n2. n1 is a 1 here, n1 is a 1. So z by 0.5 z by 0.5 whole power 1 minus z by 0.5 whole power infinite plus 1 whole divided by 1 minus z by 0.5, and this z by 0.5. Z by 0.5, the value is less than 1. This is a condition we have. When it is in the form of sum of n is equal to 1 to infinite z by 0.5 whole power n is equal to. Okay. So that you can simplify the z by 0.5 because it's a whole power 1 minus anything power infinite is a 0 whole divided by 1 minus z by 0.5. Okay. Take the z by 0.5 is a common in the denominator, numerator is get cancelled, and 1 by the z by 0.5 minus 1. So actually it is in the form of minus is there, my dear students. Actually this is a minus 0.5. Then only it is a correct. It is a minus, and keep this a minus here. The total function is equal to, and this is also minus. The total function is equal to. So multiply this minus inside the function. Now it becomes of 1 by 1 minus, because the minus 1 is becomes a plus, and this term is a minus. So 1 by 0.5 z inverse. What did I say? Not the 1 by 0.5. That is a 1 by z by 0.5. You get in the numerator. This term is get in the numerator. It's the 0.5 z inverse. Okay. So same function we got x of z is equal to 1 by 1 minus 0.5 z inverse. Okay. In the previous, when we take the 0.5 whole power n v of n, the value is the same. Here see the x of z is equal to, is a function 1 by 1 minus 1 by 2 by z. 1 by 2 the z, here z inverse. Here also it's a 1 by 1 minus 1 by 2 z only. But ROC is a difference. What is ROC here? Z by 0.5 is less than 1. Z by 0.5 is less than 1 means z is greater than, not the greater than, less than 0.5. Less than the 0.5, the ROC. Inside the circle with the 0.5, the ROC is inside. The previous case is outside. Inside means the left side in the S-line. When we consider in the circle, inside the circle, all the values of the inside the circle, the function is exist. The remaining all the values, it is not exist. Got it, my dear students? Modify this as a minus 0.5 mu of minus n minus 1. Remember this one. Both the functions, what we given the 0.5 whole power n and minus 0.5 whole power n mu of minus n minus 1. The function is the same. The x of z function. X of z function is the same, but ROC is a difference. But ROC is greater than 0.5 here, and ROC is less than the 0.5. Okay. Clear, my dear friends? Then go to the another example. See, we got the z by z minus 1. You take the common of the z here, and minus 1 minus 0.8. They're taking the 0.8 is there. It's not the 8. With a little bit confusion. Take the 0.5 only. 1 by 1 minus z inverse only. But ROC is less than. Z is less than the 0.5. Okay. Other example, n into delta of n. N into delta of n. What is the delta of n? Delta of n is having only the one value, either the continuous function or the discrete function. And discrete is represented and continuous is represented the same way. 1 for delta of n with the change of the variable of a t to n in the discrete. Okay. Given the function is n into delta of n. So you substitute in the Z transformation definition, x of z is equal to sum of n is equal to minus infinite to infinite, x of n, z power minus n. What is the x of n here? Sum of n is equal to minus infinite to infinite. X of n is n into delta of n, z power minus n. Okay. In this range, we have only one value for the delta. So it becomes of n into delta of n, z power minus n at n is equal to 0. The remaining all the values is becomes the delta of n is a 0. What is the delta of n when n is equal to 0? 1. So 0 for n is a 1 and z power minus 0. The total function is a 0. So x of z is a 0. What is ROC? The entire the z plane. For any values of z, x of z is a 0. No change in the function of x of z for any value of z. So the ROC is entire the z plane. Entire the z plane. So x of z is equal to 0 for n delta of n. If it is a delta of n, the value is 1 because there is no any n multiplied. X of n is equal to, and x of n is equal to delta of n. The transformation is becomes of 1. It is also finite value only. It is also finite value. Here also the ROC is the entire z plane. Got it? The similar way, the x of n is equal to delta of n minus 4. Even it is shifted towards the right side and shifted towards the left side, the value is the 1. The value is a 1 for the delta. Okay. They are asking here the x of n is equal to delta of n minus 4. So delta of n minus 4 shifting towards the right side with 4 samples. So now it becomes of the 0, 1, 2, 3, all values is a 0 because it shifted towards the 4. Add to 4, the value is a 1. Okay. Now, in the definition of x of z, delta of n minus 4, so sum of n is equal to minus infinite to infinite. X of n, z power minus n. So what is the delta of x of n given? Minus infinite to infinite, delta of n minus 4, z power minus n. So the delta of n minus 4 h, the n is equal to 4 only. Okay. So z power minus n at n is equal to 4. And here the delta of n minus 4 you can also write. At n is equal to 4, the value is of 1 and z power minus 4. It becomes of 1 by z power 4. Just here. Z power minus 4. And now, when 1 by z power 4, except z is equal to 0. Except z is equal to 0, all the values is exist here. Because whenever the z is equal to 0, you can substitute 1 by 0 is a infinite. The entire the z plane is a ROC except z is equal to infinite, not the infinite 0. Okay. Similarly, the delta of n plus 3. Delta of n plus 3. Even these also the n plus 3 means at n is equal to minus 3 towards the left side. You can see the 0 delta of n plus 3. Plus means advanced function. Minus 1 is a 0. Minus 2 is also 0. And minus 3, the value is 1. Because it is shifted towards the 3 samples left side. Coming to the definition of x of z, delta of n plus 3, z power minus n at n is equal to minus 3. N is equal to minus 3. The value of delta of n plus 3 is a 1. And at n is equal to minus 3. And z power minus of minus 3 becomes of z power 3. So x of z will get for the advanced function and shifted towards the right left side with the 3 samples, z power 3. But what is ROC? ROC is towards the left side, means less than the infinite. Except the z is equal to infinite, entire the z plane is the ROC. Except z is equal to infinite. Remaining all values you can take, x of z becomes a finite value. Except z is equal to infinite, the remaining all the values of z, the function x of z is exist. Delta of n plus 1, n plus 3. Coming to the y of n here, another example, x of n plus 1 into mu of n. X of n plus 1 into mu of n. Okay. Now I am checking here the given function, substituting the z transformation definition. Sum of n is equal to minus infinite to infinite. X of n plus 1 mu of n as the function and z power minus n. What is the mu of n? The range is changes from infinite to 2, minus infinite to infinite becomes of 0 to infinite. X of n plus 1, mu of n is a 1 and z power minus n. According to the shifting property, you can write, or otherwise, let n plus 1 is equal to p. And what is the n is equal to p minus 1? Substitute here. And when n is equal to, here also change the limitations also. When n is equal to 0, because it's the first limitation here, n is equal to 0. What is the p is equal to 1? When n is equal to infinite, p is equal to infinite plus 1 is becomes nothing but infinite only. Got it? So, the function now changes to the n as a p values. P is equal to 1 to infinite. X of n plus 1 now it becomes of the p and z power minus n. N is nothing but p minus 1. P minus 1 here. Okay. Is equal to sum of p is equal to 1 to infinite x of p z power minus p and z power minus of minus 1 is a 1. Okay, my dear students. So now we can add the x of 0 to the infinite or the 1 to the infinite. According to the unilateral z transformation, this function is x of z only. Okay, minus becomes x of z into x of z. Z into x of z. Got it, my dear students? One of the property, shifting property, saying that x of n minus m, the z transformation is for positive values of m, there is a negative powers of z and multiplied with the x of z, unshifted z transformation. Now it is a n plus m for negative values of m. The transformation is z power m, positive z power and x of z. What is the m here? Instead of m, there is a 1. So x of n plus 1, the z transformation is directly you can write as m is equal to 1, the z power 1 and x of z. Got it? Is it directly you can write for the online bits, but when they're given in the 3 marks or the 4 marks means I have to show this total procedure to get z x of z. Got it, my students? If n is n, x of n plus 2, z square x of z. If n is n plus 3, z cube x of z. Okay. So next example. Here we got the z minus x of 0 also, because if it is a unilateral, definitely can add or subtract from the minus z into x of z according to the definition. Because a one-sided z transformation only we are considered. You see here, the function is a p is equal to 1 to infinite x of p z power minus p minus 1, and that is equal to sum of p is equal to 1 to infinite x of p z power minus p and the z. Now I am subtracting x of 0 z power minus 0. X of 0 z power minus 0. So the z into x of 0 is also subtracted. Got it, my students? So actually, how we got that function means, see what is p is equal to 1 to infinite x of p z power minus p into z. So unilateral z transformation means it starts from the 0 to infinite. 0 to infinite. So I'm adding the function here, sum of p is equal to 0 to, or the p is equal to 0 to the value. P is equal to 0, otherwise you can write this as a function of x of 0 z power minus 0. Got it, my students? X of 0 z power minus 0. I'm adding that and subtracting also. X of 0 z power 0. Adding and the subtraction. Got it? So x of 0 z power minus 0 means that p is equal to 0, the function is the same. So I'm rewriting this function as a p is equal to 0 to infinite x of p z power minus p into z is also there. That function, there is a z is there. For this function is multiplied with the z, and totally this function is also multiplied with the z, and this function is also multiplied with the z. Already we have z power minus p and z power minus of minus 1 is a z is there, my students. I take only this function, I am rewriting this p 1 to infinite as a 0 to infinite by adding and subtracting of x of 0 z power minus 0. Okay. Total function is multiplied with the z minus x of 0. Anything power 0 is a 1. So x of 0 into z. So according to the unilateral z transformation, the definition of z transformation is from 0 to infinite only. Z into x of z minus z into x of 0 is a total function. Now whatever the y of z is here. See that only the wrote y of z is equal to z into x of z minus z into x of 0 also. Don't confuse. Okay. But unilateral, definitely there is a subtraction or the addition of the initial value conditions also. But bidirectional means only will get z x of z only. Z x of z only. Next, another function. X of n minus 1 mu of n. X of n minus 2 mu of n. So directly you can say, according to the formula, the 2 is positive value. 2 is a positive value. This is z power minus 2. Z power minus 2 into x of z is a bidirectional z transformation, but it is a unilateral z transformation if we can take, because of it is multiplied with the mu of n. Definitely there is a subtraction occurs. Subtraction of the addition values. Got it? So see, y of n is given x of n minus 2 y of n, and the definition is minus infinite to infinite y of n z power minus n. And what is the y of n given? X of n minus 2 mu of n. X of n minus 2 mu of n z power minus n. And the mu of n is changes as limitations from 0 to infinite, and keep the values 1 here. 0 to infinite x of n minus 2 z power minus n. N minus 2 is equal to p, you can assume n is equal to p plus 2. Changing the limitations of n to the p value is minus 2 to the infinite. Minus 2 to the infinite. So substitute here the n minus 2 is a p and n is a p plus 2. So p, sum of p is equal to minus 2 to the infinite x of p z power minus p z power minus 2. Got it, my dear students? Now z power minus 2 we can take as a common term, or the common multiplication factor. What is the function remaining here? The sum of p is equal to minus 2 to infinite x of p z power minus p. What is the before value of minus 2 is a minus 1. Minus 1 means x of minus 1 and z power minus of minus 1. Okay, so z power minus 2 we can multiply before the value if I am taking here. So here the p sum of p is equal to minus 2 infinite x of p z power minus p. So what is the before the substituting the values of the p, x of minus 1 is a before value is a minus 1. Okay, minus 1. That minus 1 as not the minus 1 value by the students. Before you can go the minus 1, and here it is the okay minus 1 only. So x of minus 1 if I am taking, and the p value is also minus 1. So z power minus 1 is becomes of a z power 1. And what is this before value is 0. Okay, that 0 value. What is the 0 here? X of 0, not the 0. Okay, 0 and the z power 0 value. Minus 1 and minus 2, that is after value, my dear students. Minus 2 is there, means definitely that is a after value only. Don't think that is a before the value. Z into x of minus 1 and z square, when substituted is a z square into x of minus 2 when after the expansion, and minus 2 minus 1 and the 0 is also there. What is the 0? X of 0 into z, x of 0 into the z value, and so on. So if we can add these two functions, I am not taking this function here, only if I am taking this one, z power minus 2 and minus 1 and the minus 2 is there. It is also becomes of p minus 2. Minus 2 means is a minus 3 you have to take actually. minus 1 z power 1 and minus 2p will be the value, and minus 2 to the minus 1 if I am taking, and 0 to infinite. Actually, that we have to take them. So I am taking this one as sum of p is equal to minus 2 to the minus 1 x of p z power minus p plus minus 2 minus 1 we got, and sum of p is equal to 0 to infinite x of p z power minus p. This is the equation actually. X of minus 2 is there, x of minus 2 z power minus 2. So z power minus 2, you can expand these two functions as x of minus 2 z power minus of minus is becomes of plus z square plus, and x of minus 1 z power minus of minus is a 1. Got it, my dear students? Plus, and this total function, you see here, this total function is a unilateral z transformation only, x of z. Got it? That is the way we got it. Is in between only, internally we have. But minus 1 and the minus 2 will take their functions, and 0 to infinite the another function x of z. Now I can multiply this function with z power minus 2 and z power square here. It becomes of x of minus 2 and plus, and z power minus 2 z power 1 is x of z power minus 1, because basis are same, we can add the powers. Minus 2 plus 1 is a minus 1. So x of minus 1 into z power minus 1 plus, and x of z into z power minus 2 is a function after expanding the y of z is equal to. So y of z is equal to x of z z power minus 2 and x of minus 1 z power minus 1 and x of minus 2. Got it? But what is ROC? ROC is because it is a mu of n, is greater than the 2 only. Greater than the 2. The ROC is greater than the 2 because its value starts from the p plus n minus 2 is there here. The function n minus 2, mu of n